Hello everyone, welcome to the next tutorial for Stata. So today we are actually going to learn how to conduct t-tests. So what we're going to ask you to do is to go to the linked folder and download the folder topic 7. And after you download the folder topic 7, you're going to see that within that folder, there are two different datasets. The topic 7.do, which is the do file that I'm going to show you today, and the height.dta, which is the dataset that we're going to be using. So like always, we're going to start with what I usually call the first 4 lines of code, which is clear, cd, capture log close, lock using append. And then after that, I'm going to write out the code to open the dataset. So this should be a routine for everybody to do. These 4 lines of code really saves you from all the future headaches and future troubles. Okay. So these are the codes that I currently have. I'm going to make the codes a little bit bigger so it's easier for you guys to see. So I clear my existing workspace and then I change my working directory to that specific folder. And then I closed any log file that I currently have. And then I started logging using this new log file called the t-test append, and I use hide.dta. And after I click do, I can see that my dataset has been loaded. And you can see that this dataset is actually relatively simple. This dataset only has two variables, height m and height w. So if I show you this, you're going to see that there's actually just two variables, and each variable, if you go to the bottom, you're going to see that there are 1 million observations. So basically, these are the observations of 1 million men and 1 million women's height measured in inches. Okay, so you can see the label is height in inches, the American men and 1 million American men and 1 million American women. So these are, 1 million men's height and 1 million women's height. And today we're going to be using this data set to learn how to conduct some t-test. So first thing first, before we do anything, we're just curious about the American men's height and American women's height in our sample. So I'm just going to conduct a quick summary statistic just to see what's going on here. You can see that we have 1 million observations, and we see that the average height of men is about 69.5 inches, and the average height of women is about 64.5 inches. So in the United States, on average, from our sample, men are about 5 inches taller than women. And then we have the min and the max. The tallest man is 83.15 inches. The tallest woman in our sample is 75.88 inches. Okay, so given that this is our sample, my research question is, um, are men taller than women in the population? Remember, currently we have the sample, we don't have the population, but we're going to make some extrapolation about the population given our sample. So I want to test whether in the population, men's average height is higher than the 64.504, which is the average women's height in our sample. I just want to know whether men are taller than women. Okay, so that's probably the easiest question that we can ask, and the way to do that is to use a t-test. Okay, so the code for t-test is very simple. It's just t-test. So if we just type help t-test, you can see that the syntax is incredibly easy. So we're going to be focusing on two different types of t-test. The first t-test is we're going to conduct our hypothesis testing to test a parameter, which is population average, population mean, against a specific hypothesized value. In our case, it's going to be the average women's height in our sample, 64.504. Okay. On top of that, we're going to conduct one more advanced version of this test, which is the two sample test. Basically, I'm just going to be comparing whether the distribution of men's height and the distribution of women's height are the same or not. Okay, given our sample. And we're going to be focusing on this specific option called unpaired. And I'm going to talk about that a little bit later. Okay, so for now, we're going to conduct the t-test. So basically right now, I want to conduct a hypothesis testing of whether the average height of man is 64.504 inches. Okay, so that is what I'm trying to test. So using the syntax, very simple. I just type t-test, and then I type the variable name, height of man, equals to our hypothesized value, 64.504. And if I click do, you can see that now we have a brand new table. So first of all, the top part of the table is basically replication of the summary statistics that we saw before with the observations, mean, standard deviation, standard error, confidence interval. Okay, we're going to shift our focus onto the bottom part of this table. So first of all, you can see that Stata is telling you that for the rest of the table, for the rest of this output, mean equals to the mean of the height of man. So basically, they're going to call this mean to be the average height of man, which is our hypothesized testing for the parameter, meaning the parameter that we're trying to test on. Okay, so mean height of man. And then on top of that, we get the degrees of freedom, which is sample size minus the number of parameters we're trying to estimate, which is 1. So it's going to be 999,999. And the null hypothesis here is already being written for us, which is the average height of man. Again, this mean is the mean height of man. The average height of man equals to 64.504. And since in our code, you can see that we only wrote out the null hypothesis, we did not write out the alternative hypothesis, Stata has pretty much done all of the alternative hypotheses for us. So if we focus on the middle, you can see that this HA, which is the alternative hypothesis, this alternative hypothesis is the average height of man does not equal to 64.504. So null hypothesis is equal to, alternative hypothesis is does not equal to, so that means this is the two-tailed test. And underneath that, this is just the p-value. So the p-value equals to 0.0000. Okay? So remember, the way to reject the null hypothesis using the p-value method is to measure, measure whether the p-value is less than our significance level. The significance level in economics usually is used as 1%, 5%, 10%. And since this 0.0000 is less than 1%, less than 5%, less than 10%, then we reject the null hypothesis at the 1% significance level and accept the alternative hypothesis, which is we can use our sample and conclude that the population height of man is now 64.504 and 99% confidence. Okay. So on top of that, we have two different versions of the alternative hypotheses for one-tailed tests. Okay, so this is the two-tailed test. These are the one-tailed test because we only allow the hypothesized value to fall on one side of the distribution. Okay, so we can see that we have two different alternative tests. So which one are we going to be looking at? Well, this goes back to our summary statistic. So looking at our summary statistic of the sample, we can see that men are taller than women from our sample. Which means if we believe that our sample is good, then we should use this hypothesis, the alternative hypothesis, meaning that we should believe that the height of man in the population should be greater than 64.504 because that is the average height of women in our sample. Meaning basically alternative hypothesis is the hypothesis we're trying to accept. So the logical step following our data, what our data is telling us is that we should believe that in the population, men are taller than 64.504 inches. So this should be our alternative hypothesis, and the p-value is 0.0000 because again, is less than the significance levels of 1, 5, and 10%. Therefore, we reject the null hypothesis, accept the alternative hypothesis here, which is in a population we are 99% sure that the true population height of men on average is gonna be taller than 64.504 inches. So looking at this two-tailed test and this one-tailed test, we can actually make two conclusions. First of all, men's height is not 64.504 in the population and 99% confidence. And at the same time, men's height should be greater than 64.504 inches and 99% confidence. And the reason we ignore this alternative hypothesis, this version of the one-tailed test, is very simple because the alternative hypothesis is just simply unreasonable. Because again, looking at the samples, you can see that women in our sample are shorter than men. So why would you set up an alternative hypothesis, by the way, which is the hypothesis that you're trying to accept, meaning that you believe the hypothesis, the alternative hypothesis to be the true hypothesis? Why would you make this ridiculous alternative hypothesis, which is men are shorter than women? That makes no sense. So we don't even look at this result, and the p-value does not really tell us anything. Okay, so this is a very simple way of conducting the t-test against a hypothesized value. On top of that, it's possible that I want to ask the question, are men and women have different heights? So if that is the question, then testing the average height of man against a specific number is not exactly that reasonable, because now we're looking at the height distribution of men and the height distribution of women. We're looking at two distributions instead of one distribution against a mean value, right? So if that is the case, we need to conduct a hypothesis test of whether the height of men equal to the height of women. So if we conduct this hypothesis test, what we're trying to do is we're trying to understand, does gender or does somebody's sex affect their height? Or does gender or sex matter in terms of people's height? And in order to do that, we're now going to test one variable against a specific number. We're going to be testing one parameter against another parameter. So here I'm testing whether average height of men in the population equals to the average height of women in the population. And on top of that, I'm going to add this new condition called unpaired, this option called unpaired. And the reason I use this unpaired is because I'm trying to tell Stata, remember, these are 1 million men and 1 million women. I'm not comparing the first man with the first woman and the second man with the second woman and a third man with the third woman, because I'm not saying that these two are a pair and these two are a pair, because it's just 1 million men and 1 million women. I'm just testing them overall. So I need to tell Stata that they're not paired. So whether you use this unpaired option depends on the specific data set or depend on the specific research question that you're looking at. For example, instead of looking at whether height of men and height of women are different, if I'm trying to study whether, let's say, two different clothing stores have the same price of their clothing or not, then if the first variable, the first observation are the t-shirts, and the second observations, second observation are the pants, and the third observation are the jeans, and the fourth observation are the coats, then this observation for store one and this observation for store two should be paired, because now we're looking at the t-shirt prices, we're comparing the t-shirt prices, and now we're looking at the pants prices, and now we're looking at the jeans prices, and now we're looking at the coat prices, right? So in that case, these variables will be paired. So we wouldn't use that unpaired option. But in our case, we don't care. These are not a paired group. Therefore, we tell Stata to use unpaired. So if I click do again, we can see that again, it conducts that summary statistics for us. And then afterwards, again, this is the hypothesis test. You know, Stata starts calling this average height of men minus the average height of women to be diff, just to make it manageable when it comes to formatting wise. Okay, so the alternative hypothesis is the difference between the height of man and the height of women equals to zero. Basically means height of man and height of women are the same, right? That's the alternative hypothesis. Sorry, the null hypothesis. And then we have the alternative hypothesis. Again, in the middle is the two-tailed test, which is usually the test that economists use. So the alternative hypothesis is the difference does not equal to zero, meaning that men and women have different average heights. And if you look at the p-value, it's 0.0000, which means we reject the null hypothesis, accept the alternative hypothesis. As a result, we're basically saying men and women have different average heights. And we can look at the other alternative hypothesis, which is difference is greater than zero, meaning men are taller than women on average, which is a reasonable alternative hypothesis. You can see that the p-value is 0.0000. Reject the null hypothesis, accept the alternative hypothesis, meaning that men on average are taller than women. Again, this alternative hypothesis, which is difference is less than zero, meaning men on average are shorter than women is just a ridiculous alternative hypothesis. This is not the alternative hypothesis that we're trying to accept, so we do not look at the result of this. So the important thing to understand here is that Stata conducts all of the hypothesis testings for you because you did not specify which alternative hypothesis you are trying to use. So it's up to you to decide which one-tailed alternative hypothesis to choose when you're making your conclusions from your research question. But the middle one is always the two-tailed test, and the left and right ones are always the one-tailed test. You always choose one, not the other, because there's always a alternative hypothesis that makes more sense that you're trying to accept. Okay, so this is how you conduct t-test using Stata. Okay, thank you.